Hello everyone, and welcome to Lesson 8.1, Solving Trig Equations Using Inverses. So far in trigonometry, we've learned if we're given an angle, that'll be our input, and our output will be the sine of that angle, or the cosine of that angle, or the tangent of that angle. Now we can also use the inverse to work backwards. Maybe we're given a ratio, or given side lengths, and we want to find the angle. So to do that, we're going to use inverse trigonometry. So we will start this lesson by defining and evaluating inverse trig functions, what the equation looks like, what the graph looks like, how we have to restrict the domain, and then we're going to work on solving. So we'll start by defining inverse trig. How can we derive the inverse trig function, how to restrict the domain, and why would we use an inverse function? What's the purpose? So the first thing we need to understand is what a function is. A function, each value of the domain, each x value can only go to one y value. So y equals the sine of x is a function. If I put an angle value in for x, I get a value out for y. So remember, if we put pi over 2 in for x, sine of pi over 2 is 1. We could also go backwards, go to negative 3 pi over 2, also has a maximum of 1. But each x is exactly 1y. Now, the problem with the sine function is it repeats. So the sine function is a function, but the inverse, we're going to have to restrict the domain. Because if I have these 2 points, so I have negative 3 pi over 2, comma 1, and pi over 2, comma 1, if I wrote the inverse points, x would be 1 in both cases, and it would go to 2 different y's. So the inverse is not a function unless we restrict the domain. Okay, the inverse, we're going to be given the ratio, and we're going to have to find the angle. So the way we do this is we're going to restrict the domain, and for sine, we restrict the domain where the graph is increasing. So we say the domain of the inverse function is from negative pi over 2 to pi over 2. That way, the inverse will have all different x's. Okay, we're not going to have a repeated height in the sine function. Therefore, we won't have a repeated x value in the inverse sine function. Okay, and this blue function is what the inverse looks like. It's still reflected over the line y equals x. And the inverse sine function will always give us a value between negative pi over 2 and pi over 2 if we're in radians, or it'll give us a value between negative 90 and 90 if we're in degrees. Okay, a lot of times we're going to work in radians. So we're going to look at a portion of the graph where the function is always increasing, and then sometimes we're going to have to extrapolate and figure out, are there other possible answers that our calculator that this function won't give us, but actually exist? So the inverse sine function has a domain restriction of negative pi over 2 to pi over 2, and then the range is negative 1 to positive 1. So why would we use these? In a normal sine function, the input is the angle and the output is the ratio. The inverse function, the inverse sine function, our input is now the ratio and the output is the angle. So we are looking for the measure of the angle. So if the problem involves a missing angle, we're going to use inverse sine. So let's look at a few examples. Okay, we're going to look at how should we restrict cosine of x. If we want to write the inverse cosine, what is the domain there? Think of a part of the function where it's always increasing or always decreasing. Okay, unless what you think the domain of the inverse cosine function would be. So the inverse cosine function, okay, we're going to restrict slightly differently. Okay, we're going to restrict the inverse cosine from 0 to pi, because from 0 to pi, it's always decreasing. So sine was negative pi over 2 to pi over 2. Inverse cosine, the domain is going to be between 0 and pi. So your inverse cosine is always going to give you an angle in the first or the second quadrants. Okay, if we're dealing with a positive cosine value, it'll give you a first quadrant angle. If you're given a negative cosine value, it's going to be a second quadrant angle. So we could also restrict inverse tangent, but we'll talk about that another time. So if we're dealing with sine, okay, the outputs are going to be from negative pi over 2 to pi over 2 for inverse sine. And if we're dealing with inverse cosine, your values are going to be between 0 and pi. Okay, they're going to be negative for sine if we're in the fourth quadrant, positive if we're in the first quadrant, and cosine, okay, depending on where we are, either first or second quadrant. So let's think about this question. What is this question asking? And then how do I go about finding the answer? So the question says, what's the inverse sine of 1/2? The question is saying, what angle has a sine value of 1/2? So I got to think about, first off, where is this angle? The sine value is the y, so I know that the angle's got to be in the first or the second quadrant. Okay, now if I took inverse sine of 1/2 from my calculator, it's only going to give me one number. Okay, it's only going to give me an angle, but either between negative pi over 2 and pi over 2, either in the first or the fourth quadrants. So I know I'm going to get an answer for the first quadrant, and then I'm going to have to take that and find the angle in the second quadrant. So the first thing I do, and I can use a calculator, or if it's a special ratio, I can tell myself the angle. Okay, so I think about what angle gives us a y value, y coordinate of 1/2. And I remember that's 30 degrees. Okay, or pi over 6. Now that is the singular answer, but the answer doesn't include, so we may get to a point where it says what are two angles that have an inverse sine of 1/2. Okay, we could also say if it's 30 degrees here, it could be 150 degrees in quadrant 2. So the unit circle is going to be very helpful, especially when we have 1/2 or square root of 3 over 2 or square root of 2 over 2. Now you get to try this one. What's the inverse cosine of square root of 2 over 2? Pause the video, test it out. We'll see if we got it. Okay, so we got to think about what part of the unit circle has an x coordinate of square root of 2 over 2. Okay, it's positive, so I know it's in the first quadrant. And 45 degrees or pi over 4 would be my answer. Now here comes the challenge. What's the inverse tangent of negative square root of 3? So here's the unit circle if you want some assistance. Test it out on our calculator, see if we get a value. And we get that it's negative 60 degrees or negative pi over 3. So our answer here is going to give us the fourth quadrant angle, okay, which is right here. Okay, and it's going to tell us it's negative 60 degrees, which is also the same as 300 degrees. If you do the tangent of negative 60 or the tangent of 300 in degrees, you'll get negative root 3 as an answer. Also, the other angle that would work is 120 degrees. The inverse tangent of negative square root of 3 also could be 120 degrees, but your calculator is only going to give you, for tangent, the first or the fourth quadrant. Very similar to sine. Now, a much more tangible application is a problem like this one. So a building is 20 feet tall, the length of the shadow is 10 feet long, the building and the ground form a right angle. What is the angle of elevation from the end of the building's shadow to the top of the building? So just like we drew triangles and solved situation problems, we're going to do the same thing here. So I want you to pause the video, set it up, think if you can create the equation and then solve the equation using inverse trigonometry. Okay, let's check how you did. Okay, we got this triangle, we have the shadow on the ground and the height of the building, and it tells us that the building is 20 feet tall, and then the shadow is 10 feet long. It wants the angle of elevation down here, so we could set up a ratio. So I have opposite and adjacent, so I'm going to use the tangent ratio. So if I ever get a problem like this, to undo tangent, I use the inverse tangent. So I use the inverse tangent of opposite over adjacent, which is 20 over 10, and get 63.4 degrees. Now this one can only have one answer because this angle we're going to count as a positive angle, and it's got to be an acute angle because it's within a triangle. So when I'm using inverse trig, I have the ratio and I'm trying to find the missing angle. Now, depending on what I want, my calculator is always going to give me a singular answer if I use the inverse sine or inverse cosine or inverse tangent. But we also have to be aware, we're going to see this more in day 2, that there are 2 possible angles that'll give you a certain ratio based on our knowledge of sine being the y coordinate and cosine being the x coordinate.